Good afternoon everyone. In this video we are going to discuss about how we can solve the second order differential equation by using MATLAB. The process of solving the second order differential equation is first to convert the second order differential equation into two simultaneous differential equation, and then after that you know how to solve it. Okay, so the only thing is you need to know how to convert a second order differential equation into a first order differential equation. That's it. So I'm just taking one example. This is the pendulum motion, and say the differential equation for the pendulum motion is given d2 theta by dt square. d2 theta by dt square, this is given by minus omega square sine of theta. And what you want to find out the solution of this differential equation, and what is given to you. The given values are the value of theta at time t is equal to 0 is 0, okay, and the value of theta dot at time t is equal to 0 is basically 1. Now you want to find out the value of how the theta changes with t, and how the velocity, which is d theta by dt, also changes with t. So you want the value of theta with t. You also want the theta dot versus t. This you want. So this is second order differential equation, and I think most of you know how to convert a second order differential equation into a simultaneous differential equation, right? So let's begin with this. Let t theta by dt, is equal to y. Okay, so the moment I say d theta by dt is equal to y, this is one differential equation. This is your one differential equation 1, and with this differential equation I can write here what is the value of theta when time t is equal to 0. This is the initial condition to solve this first order differential equation, and it is given, it is 0. Okay, now the moment we have written d theta by dt is equal to y, it has given me one differential equation. And now if you put this value d theta over dt into this differential equation, we can write d2 theta by dt square is nothing but it is basically dy by dt. So from this equation I can write dy by dt. dy by dt is what? dy by dt is minus omega square, which is the angular velocity given, and then I can write here sine of theta. Say this is differential. Say this is your second equation, and in order to solve this equation, dy by dt is equal to minus omega square sine of theta, which is a first order differential equation. What we want what is the value of y at t is equal to 0, and what is actually y is equal to basically d theta by dt, means y is basically theta dot. So this we already know, the value of theta dot at t is equal to 0 is given, this is equal to 1. So actually now you have two simultaneous differential equation having two functions. This is the one function and this is the another function with two initial values, and the next one is the t span. Again you say the t span, you want to see the solution of t span, say from 0 to say 10. So now you have all the values. So again the process is same. You define this, say with some name theta 0. If you want to write, say you want to write theta 0. So theta 0, what is the value of theta 0? Theta 0 is your 0. Now after that, if you want to write theta dot 0, so you write theta th dot, you write th underscore dot or theta dot. So you write th dot. What is the value of th dot? That is initial condition is 1. It is up to you if you want to write them as u0 v0. Same way we can also write here. Now z0, Z0 is what? Z0 is your TH0 and semicolon TH dot 0 if you want to write, that you can also write. Now after that, the function you need to write. Function of course you'll write in one function file, and we need this tspan value, so I'm writing tspan. This tspan is say 0 and 10, and the function, let me write the same function I'm writing here, say t and z. So if I'm using the OD45, I'll use the OD45 function. Let me write down the function name, and that function name is say fun. This is for the OD2, so let me write the name is say OD2, and then I'm writing here tspan, and the initial value is z0. So the moment you solve it, here in z the first column, in z the first column, in z the first column is having the solution of what? It is having the solution of this theta. So the first column is actually going to give the solution of theta, and the second column of this is going to have the solution of y. And what is y? Y is basically theta dot, the velocity. So this will give you the position, angular position, and this will give you the angular velocity. So you know, in order to solve this equation, if you want to see the solution in a graphical form, you can write plot. Here you write t, and then you write same z1, and this is for your if you want to differentiate with some solid line and dashed line, say this is the solid line, red color. Then you have t comma, this 2 1, and say you want this is dashed line in blue color. If you want to write down the legend, you can write first for the theta and second for the theta dot, or you write the angular velocity, so that you can mention. Next important thing is about the function. So let me write down the function file. We have already seen how to write down the function file. The first we'll write the function line, function, and then here the output is, say I'm writing the same output name is z dot, okay, and then the function file name I've written, I think fun, and it is OD2, so I've written OD2, and here again we'll write down the t comma z, and z dot, easily you can write z dot is having some function, and the first function is what? So when you are going to solve any second order differential equation, you are going to assume this one. So your always first function will be this one only. So first is theta, and second is basically y. So we can write theta is basically z1, we have written here, and theta dot or y, theta dot, you say the theta dot or you say y, okay, this is with z2. So while writing the function, first we'll write down for this one, which is for the d theta by dt, and it is basically y. So y is what? z2. So in case of second order differential equation, we are going to assume this. So always the first function will be z2. So always the first function will be z2. What is the second function? Second function is minus omega square sine theta. Okay. So you need to write down what is the value of omega. So maybe you can define omega square. You write down this omega square with I'm writing the name omega sq, and if you say this value is say 1.56, directly I'm writing the value of omega square with the name omega sq. So minus omega square into sine of theta. So I'll write sine, and what is theta? Theta is z1, sine of z1. Close this and close this. Close this function. Ez. Now this function is also ready, and if you run this command, it will give you the solution of theta as well as the theta dot at different given time. Just to show this, let me create a new file with the name let me write down the name. It is ODE2. Okay, ODE2. So this is for solution of second order differential equation. So we have written for theta 0, so let me write theta 0. Theta 0 is 0, and then I'm writing theta dot. Let me write it 0. उसमें कुछ भी नहीं, जो भी आप नाम लिखना चाहें लिख सकते हैं, वहाँ मैंने 0 नहीं लिखा था. So theta dot 0 is, say I'm writing 1, and then I'm storing this z0 with the name of theta 0, and then theta th dot 0. Right, I hope the name is clear. Okay. Then we have t-span. The t-span, again I'm writing, say I'm taking the value, say 0 to 10, and then we have to solve it. So let's write the same output variable name, and solver is, say, ODE45, and the function file name, I'm using the function file name is, say, fun underscore ODE2. Okay, and then here t-span, and then z0 values, whatever the value of plot we want to see. Here t versus theta, so I'm writing the name, this one, and suppose this you want in a solid line with the red color, and then you want t versus theta dot, which is the velocity. You can say theta dot, and this is stored in the second column, and you want to in a dashed line blue color. If you want to write down the legend, that legend you can also write. The first is for the you can say just first you can write down the angular displacement, and second you can write theta dot is angular velocity. This is one plot. One plot you can also make is, say, what is the variation of theta and theta dot. So if you want to see the variation of this, you can use a plot how this theta and theta dot vary with each other. So this, and say z. See, I hope everything is fine. If everything is fine, it will run. Okay, it is doing something from masses. Okay, masses is because we have not created the file yet. Fun underscore ODE2. So let me create the file. Create the file with the name fun underscore ODE2. This is a function file. So function file will the name we have written here is a dot, and the function file name is fun underscore ODE2, and the input are basically x and t, t and z, and z dot we have written store the value. First one is always z2. We have seen it is always z2, and then we have something like minus omega square. So just I have defined that omega square with omega sq. See, the value is 1.56. So we can write minus omega sq is minus omega square into sine of theta. So the sine, and theta is basically z1. So we write z1. Close this. If everything is fine, see, we'll see the two plots. This is the plot 1. This plot 1 is showing you, the one is in the angular displacement, which is theta, and see, we have written that t is equal to and t is equal to 0. The position is also 0, and for the velocity you have given the initial condition at t is equal to 0, it is 1. So this is just a solution of angular velocity and time. And if you want to see the variation of the this one, where it is. Yes, it's here. Yeah, you see it is circular. It is circular in nature almost. We have not set the axis, so it is circular. Yeah, almost circular. So this is the variation of angular velocity. On x axis we have angular displacement, and on the y axis we have the angular velocity. So this is how you can solve any second order differential equation. Just you need to know how to convert the logic, how to convert any second order differential equation into a first order differential equation. And again, just to have a quick review, if this is a given differential equation second order, a condition is given to you, you have to solve it. The first job is to convert this into a simultaneous differential equation, and in that case you will just assume that d theta over dt is equal to y. The moment you assume this, you will get one differential equation, and for this differential equation to solve, you need to know what is the value of theta at any given initial time t, which is already given to you. Now if you put this value into this equation, you will find out dy over dt is equal to minus omega square sine theta. This is your second differential equation. And in order to solve this differential equation, you need what is the value of y at t is equal to 0. What is y? Y is basically theta dot. So you want to know what is the theta dot at t is equal to 0, which is also given here. So just I have written here. So now we have two differential equation, and these two differential equation you already know how to solve it. Okay, so this is all about the solution of second order differential equation.